To get started, let's first visit the attack range project. Now, again, in this case, we'll be using the local attack range for this demo. But as I mentioned, there are various versions of the attack range. There's the local version, which is meant to be run with Vagrant and VirtualBox in your local machine. And specifically, we've tested it to run on Linux and Mac OS operating systems. On our current demo, I'll be using a Ubuntu 18.04 machine as the operating system, where I'll be running it with the latest version of Vagrant and VirtualBox. But you can also run the attack range, or the proper attack range project, using Terraform on AWS or Azure as a cloud service. Now, there's some big distinct differences between these two. The major difference is the local attack range leverages snapshots in time of Windows clients and or Windows Server, whereas the cloud version will have the latest patch version. So if you're testing a CVE that doesn't work against a patched Windows version, you may be looking at using the local attack range. Meanwhile, if you're testing something that's a 0-day or looking for a TTP for cloud attack range may be a better option. Another big thing to consider is cloud attack range can scale properly, and you can share with the other team members as you're working with it. Whereas the local attack range really is not meant to be shared. We also have a beta cloud-only attack range, which is built to collect specifically serverless events from an environment. And this is using a slightly different architecture, and it's specifically built for AWS. Like I mentioned, it's still currently in beta, but we're using it heavily to develop cloud detections. Now, let's get started with the local attack range for the purpose of this demo. Now, the local attack range, in order to install it, we just need to clone the project, and there's a nice installation guide here that we can use. Again, since my machine is Ubuntu 18.04, I'll be following the Ubuntu guide. Now for the Ubuntu guide, we can either copy and paste this into a script or just run it locally in a terminal window. And this simple script uses apt-get to install all the dependencies that we would need, like Vagrant and VirtualBox, as well as some Ruby gems that we need to be able to control the machine, WinRM specifically, and then clones the project, installs a virtual environment under Python 3 in a folder called venv, and then installs the dependencies for our project. To get us started, I'll simply copy and paste this into let me move here to a workspace. Make sure I don't have any, and I'm gonna go ahead and copy and paste this under attack range, deploy script.sh. I would save it. I'm going to make it executable and run it. It's gonna ask you for your sudo password on that machine. And by the end of it, we should have already a installed and ready to go attack range. All right, so if I go into the attack range local folder, I should have virtual environment, which I'm gonna go ahead and activate. And if I try attack range here, boom, excellent. Now the attack range on the its interface is basically a command line tool, and the command line tool takes in, and it's required, a set of actions. We support this handful set of actions, very specifically build, which builds an environment, an attack range that you configured. Destroyed, completely destroys that environment. Simulate allows you to run a atomic red team simulation against that environment. Stop stops essentially the virtual machines but it doesn't destroy them. Resumes the virtual machines, and dump. And what dump does is it dumps all the logs from Splunk collected for that for whatever it's been indexed so far. So the workflow is you launch a bunch of attacks, and then you want to store those logs somewhere or replay them. At some point, you can just run dump, and it essentially saves those logs locally. Optional parameters are if you're simulating, you can pass it a target, and I'll show you during the demo how this works. And then a simulation technique, and this corresponds to the atomic red team technique. Again, I'll show you in the demo how this works. And another set of options is list machines. So again, once you build an attack range, if you have machines running, you can just run LM and it shows you which machines are available. Yeah, so let's get started. Let's build the range. Go ahead and just run Python. Oh, I forgot action. Build. And again, by default, it builds a Windows domain controller. It usually takes about 10 to 15 minutes to get a build for Splunk Server and Windows domain controller. If you're building with a Basel SOC data set, it typically adds another 10 minutes in there because they're pretty large, and on the hood it needs to download them into the VirtualBox machine, into the virtual machine. Now what you may not see here is that it's spun up VirtualBox, and it's here. I'm going to try to set this window side by side. It's now running Ansible to configure these machines. So the attack range will go ahead and instantiate the machines, and then with Ansible we install all the software we would need, Splunk, right, with all its TAs pre-configured, and then also in the Windows domain controller it's going to go ahead and install the universal forwarder plus all the different adversarial simulation agents from Caldera and Atomic Red Team. Now, as you can see, it's starting to build the Windows domain controller. Usually, again, the build process for the Windows domain controller entails not only configuring the different components for Splunk and adversarial simulation, but also configuring Windows itself, right? The different logging policies, and again, essentially disabling things like Windows Defender you see here, which may get in the way when testing certain attacks. Now, this saves us a whole lot of time when we're doing detection development, and it gives us a replicable platform. This is one of the massive values, again, the attack range gives our team when we're trying to emulate something. It usually would take a researcher 2 to 3 days to get an environment exactly right for testing, whereas with the range, again, now we're doing it here in a handful of minutes. Now that we have a build attack range, the next thing we can do is try to run, let's run list machines. So LM, again, will display the machines that are running, even though we see them here. And as it says, we've built a Splunk server and a domain controller. Before we jump into any of these, I want to run quickly an attack simulation against the domain controller, and specifically, just for the purposes of demo, I want to run credential dumping. And before I run the attack, let me show you how this is structured. If you go to the atomic, if I can spell it right, Atomic Red Team project, where the actual attacks again are coming from that we're referencing, and we go under atomics, they're broken down by their respective MITRE technique. So I'm just going to select T1003.002, which, if you go to the README, this corresponds to a security account manager, and specifically is different Credential dumping attacks against a security account manager. There's specifically 4 under this technique, or 4 atomics. One is dumping SAM creds and secrets via the registry. Another one is parsing the registry with PyPyCats. Another one is making a copy of SAM using ESET UTL. And finally, the last example is using power dump, registry dump, to dump the SAM hashes and usernames. And again, I'm just going to click on the first one. There's a nice explanation on the Atomic Red Team project of what the attack is and how it's getting executed. Let's launch this attack. So I'm going to flip back to the attack range, and to run a simulation using Atomic Red Team, again, we run the attack range. In this case, we're going to use action simulate, and then we're going to pass it a target, and the target is going to be the name of your machine in this case. And then we'll pass it a simulation technique, ST, and we said the simulation technique is T1003.002, and we hit enter. And what this is going to do is it's going to go ahead and launch Atomic Red Team with that specific simulation and run those 4 attacks on that machine. And what I want to do is, after this is done, is I want to jump into the Splunk server and then show you how we can run a search or detections to catch this attack, since we've already built them. And ran the simulation, it cleans up, and at the end you should get a nice message saying, hey, successfully executed the technique ID against the target. Now, let me list machines again. And here, let me jump into the Splunk server. This is going to be running on HTTP:// port 8000. There's our Splunk server, admin, and the password, by the way, it's on the config file. I never changed it from default. Here, let me just copy and paste it. This is the password. And again, as I mentioned earlier, there's a landing page in the attack range that tells you how many simulations I've ran against it, what MITRE technique, we launched my MITRE technique for simulations, and the different machines that got attacked, so on and so forth, techniques and tactics. Now, I'm gonna quickly just jump into the enterprise security content update just to show you how we can catch one of those atomics that we just launched. Specifically, we have a analytic story here, which is basically a grouping of detections for credential dumping. We have a handful here, different ways that you can access credentials in an operating system. But specifically here, we're looking for credential dumping through registry here. Attempted credential dump from registry via reg.exe. So if I drop this down, there's my search for this is using the endpoint data model and looking for a process name of reg.exe or command.exe with a keyword in the command line arguments of save and any of these arguments as well. So these are the different registry keys that you point to dump credentials from. And then this is just cleaning up the end of the search. So I'm going to go ahead and run this for the last 24 hours since we just ran the attack 10 minutes ago, or not even 2 minutes ago. And we can actually see here that the search successfully catches those commands, right, from Atomic Red Team, reg save HKLM-SAM into a local directory, so on and so forth. And again, this is a way where we just built an environment where we simulated an attack against a domain controller, and then we're able to catch it using Splunk on normalized data. Now for Ryuk, the first thing I'm going to do here is I have a blog we wrote, like specifically how we went about developing detections in the attack range, in the local attack range. And again, if you have time, highly recommend it. But more specifically, the reason I'm coming to this blog is we use a specific example from that we in reversing labs of a version of Ryuk, and I'm just going to go ahead and re-download this example with you here. So I have reversing labs open. I'm just going to search for the hash, And if you're not familiar with Racing Labs, they're very similar to VirusTotal in essence, but they definitely have a handful of features in there that we take advantage of. So here I found my example, keyword infected. So I'm downloading my ransomware. So now it's in my local machine. Now what I'm going to do here, again, since this is going to be a little bit more complex, I'm going to go to my Windows domain controller specific. And since again, there's not an automatic simulation for this, we have to run the ransomware ourselves. I'm going to be doing some manual work with the actual virtual machine here, but I think that's okay, right? We can log in as Vagrant, or we can log in as the domain controller user. Either one will work. I'm just going to log in as Vagrant. We don't delete the Vagrant user since it gets used for management. Right, so here's my Vagrant shared folder. I'm going to move this. I'm going to move this to desktop. Oh, what did I actually created a shortcut. I'm actually going to move it to desktop. Just close out of here. I'm going to now remove my network mappings from my shared folder. And I'm going to extract my ransomware. The password is infected. And here's our ransomware example. So move it again to my desktop, rename .exe. Yep. And the moment I run this, it's gonna take a minute, but you're gonna start seeing encrypted files in the computer. So here goes nothing. Now again, be careful if you are running a Windows host, since if you're emulating this on your end, this is live ransomware. But yeah, it did run. You see immediately it removed itself, and one of the things that you'll start seeing as this ransomware continues to pillage through our machine is it starts creating this like readme.html files in every folder it encrypts. Right, so the download folder got encrypted, PowerShell folder got encrypted, and so right, there you go. It even shows up in your desktop, and if we open it, this is the ransom note. Right, so hey, you got infected by Ryuk. We did a bunch of analysis on how Ryuk works locally. If I'm going to go ahead now and start testing detections against this box, since we're still collecting logs for it. And specifically some of the detections we talked through earlier on in the example. So let's jump back into Splunk here. And if I search for analytic stories, we do have a real ransomware story. And so more specifically, there is a handful of also again detections that we built for Ryuk. So one of them is the ransomware nodes, right? There, if we hit the search, we did find the fact that this machine, right, our domain controller now has one of the ransomware nodes dropped into it that Ryuk built, right? Stopping security account manager. It's also another great example of what Ryuk does, right? It's very odd behavior, but it does stop SAM in order to not get essentially blocked by other processes. And we do see that, again, that behavior here, net.exe called to stop SAM